Simplify each of the following expressions. Well, if we think back to our Unit 1, what we're doing is we are factoring. And as I take a closer look at this, it looks like on both of these, in the numerator, the top of the expression, and the denominator, the bottom of the expression, we are factoring the greatest common factor. And up here in the numerator, it looks like their greatest common factor is 20a, lowest exponent, by the way. And when we factor that out, we're left with 20a squared divided by 20a is a. 60 divided by 20 is 3. A divided by a is 1. Greatest common factor in the denominator is 15a, it looks like. And when we factor out 15a, 15a cubed divided by 15a is a squared. We had 3a's, we took out 1, we've got 2. And then 135 divided by 15 is 9, and we already took out the a. Well, once we get to this point here, it looks like we can factor a little bit more, and we get 20a comes equals 3. Nothing in the numerator, the top of the expression, but in the denominator, we can do the difference between two squares on a squared minus 9. And a squared is a times a. 9 is 3 times 3. Difference between two squares is different signs. And once we get to this point, what we're looking for is, do we have anything exactly the same on the top and on the bottom? Well, the a plus 3's cancel out. Another thing that I see is that there's an a here and there's an a there. So we're almost done. But we can also divide 20 by 15. And we don't really divide it. What we're looking at here is, do we have something in common in both 20 and 15? We do. It's a 5. 20 divided by 5 is 4. 15 divided by 5 is 3. And remember, everything else canceled out except for this a minus 3 down here in the denominator. And I just want to write it a little bit better. That's the right answer. But we get 4 divided by 3 times a minus 3. Problem number 2 still requires the factoring. And let's just start with the far left expression, x squared minus 10x plus 25. Feel free to split the middle. We've kind of gotten a little bit past that point, but when we factor x squared minus 10x plus 25, we end up with x minus 5 for each of those expressions. As I stop and take a quick look, that's correct. And then we have our x plus 3 here. And then in the second fraction, in the denominator, we've got 25 minus x squared. Well, 5 times 5. X squared is x times x. And the difference between two squares, different signs. And as we take a quick look on this particular problem, not much factors. But the thing that we can notice here is that we've got an x minus 5, and we've got a 5 minus x, and they're almost the same thing. What happens is the x in one of the terms is positive and the other one's negative. The 5, one of them's positive and one of them's negative. So they're the opposite sign. So what we're going to do is we're going to change one of the signs here. And in other words, I'd like to change the numerator, but it doesn't make any difference. But when we change the sign here, it's going to be negative 1. I did not change the sign on this x minus 5, but I did change the signs here. Negative x, and then it's going to be positive 5. We did not change any value there, because there's that negative 1 outside. And the reason why I like to do the negative in the numerator is because we don't like a negative in the denominator. Times 3, and I'm going to rewrite what I have circled there in blue to negative x plus 5 times 5 plus x. Now what we're looking for is, do we have anything exactly the same in the top and in the bottom? Well, we have a negative x plus 5 in the numerator. We have a negative x plus 5 in the denominator. That's the only thing that cancels. So what we're left with then is negative 1 times x minus 5 times 3, which means I'm going to do a little bit more work. Down here in the denominator, we have x plus 3 times 5 plus x. And the reason why I said I need to do a little bit more is it's negative 1 times 3 is really negative 3 times x minus 5. And one last time, x plus 3 times 5 plus x. Maybe your teacher wrote it as x plus 5 on the bottom, but that is fine right here. Multiplying, by the way, is just multiplying straight across. We multiply the numerators together, the tops of the fraction. We multiply denominators together, the bottoms of the fraction. And then eventually we got to the point where we can cancel. On problem number 3, we are subtracting. And when we subtract, once again, what we're going to have to do, whether we add or subtract, we have to find the common denominator. And if you are writing these down, what you may want to do is work on another piece of paper just for a little bit more space. And I'm not going to show quite as much work on the factoring, but for the 8x squared plus 6x plus 1, you need to split the middle. For the 2x squared minus x minus 1, also splitting the middle. And as we take a look at this, then this is 2x plus 3. And again, not showing the split the middle part here. 4x times 2x is 8x. 1 times 1 is 1, and both of those are positive. Minus, and again, going to split the middle on the denominator. 2x, x, 1, and 1, minus 2x plus 1. So as we look here, again, we are subtracting. In fact, I'm going to change the color because we need to be really careful with the subtraction. But before we get there, we need to find the common denominator. And one thing that I notice already from both of these denominators is that there's a 2x plus 1 in each of those denominators. So that's going to be part of the common denominator. So I'm going to write 2x plus 1. And then as we take a look, the other two values, the 4x plus 1 and the x minus 1, they are not common. So both of those values are going to have to be part of the common denominator. Oops, x minus 1. So over here, 4x plus 1, x minus 1. And again, we need to be really careful with the subtraction. So, we still have the 2x plus 3 up there in the numerator. That's not going to change. But now what happens is, to get this denominator here, we had to multiply. We had the 2x plus 1, it was already there. The 4x plus 1, it was already there. But we have to multiply by x minus 1 in the bottom of the fraction. Can't get those parentheses in. But then we're going to have to multiply by x minus 1 in the top as well. Same idea over here. We have a 2x plus 1 that was already there, and we have the x minus 1 already there. But to get the complete denominator, we had to multiply the bottom of the fraction by 4x plus 1, which means that we're multiplying the top of the fraction by 4x plus 1 as well, the fancy form of 1. So this is going to be minus 3 times 4x plus 1. And we still have a little work to go, because we want to combine these together. So we're going to have to multiply the 2x plus 3 times the x minus 1. So we're going to FOIL or double distribute. We get 2x squared minus 2x plus 3x minus 3. And while I'm thinking of it, might as well do the minus here, but be careful, because this minus is going to apply to this 3. So when we distribute this here, it's going to be minus 12x, but it's going to be negative 3 times 1, which is going to be negative 3. And we have our common denominator of 2x plus 1 times 4x plus 1 times x minus 1. And we're getting closer here to finishing. Looking for like terms up there in the numerator. We don't have anything with the 2x squared, but we have negative 2x plus 3x minus 12x, which is going to be 11x. And I think I have my sign wrong here. 2x plus 3x is 1. Yep, minus 11x. And then our other like terms here, minus 3 is minus 6. Then we've got the 2x plus 1 times 4x plus 1 times x minus 1. And it all looks well and good, except then the question is, can we factor 2x squared minus 11x minus 6? And again, I'm not going to show my work on split the middle, but I think that we can. And there's the factoring, and then we still have the 2x plus 1 times the 4x plus 1 times the x minus 1. And now we're darn close to finishing. Do we have anything exactly the same on the top and the bottom? Well, we have a 2x plus 1, and we have a 2x plus 1. So finally here, when we subtract, we end up with x minus 6. And then we've got 4x plus 1 and x minus 1. And there is our subtracted rational expression. Problem number 4, I'm going to rewrite. Those people who have had me for a teacher know I call it old school. The way I like to write this particular problem is x squared minus 10x plus 21 divided by x plus 2. And then here's the old school. Divided by x squared plus 4x minus 21 divided by x plus 7. Well, as we take a look at this, we're going to have to factor, but even before I factor, when dividing fractions, don't ask why, flip the second one and multiply. So I'm going to rewrite this yet again. We have x squared minus 10x plus 21 over x plus 2. Remember, we're going to flip the second one, and we're going to multiply. So this is going to be x plus 7 divided by x squared plus 4x minus 21. And now we're going to factor. It's a multiplication problem now, which we have previously done, where we're going to multiply the tops of the fractions together. We're going to multiply the bottoms of the fraction together, and then we're going to cancel. But before we multiply them, let's factor. So we factor. You can split the middle if you need to. So we're going to get x minus 7 times x minus 3. Still divided by our x plus 2. And over here, we've got x plus 7, and when we factor, plus 7 minus 3. And then as we take a look here, do we have anything exactly the same on the top and on the bottom? Well, we have an x minus 3. We have an x plus 7. And what we're left with when we finish this problem is x plus 7 over x plus 2.